this is 1H. Here's my nucleus. It's got 1 electron. It needs, we're talking about covalent, so it's sharing, so it's not taking from anybody else. So it's got to be sharing the other hydrogen's electron. So they're going to be close enough that they overlap. And now those two electrons, one from each hydrogen, are between both of them. They're between both of them. Did you have to draw these last year? No? Did you do Lewis structures for these last year? Yeah. Maybe? Will you draw stick for bonds? Or just electrons? Yeah. So if I was going to do this for Lewis structure-wise, does that look familiar?
Yes.
Okay, that's a Lewis structure, but so is this. So, the bonding electrons fall between the two atoms. So you can draw a bonding pair of electrons as 2 electrons side by side, or a stick. Each stick represents 2 electrons.
So we have to draw, can we draw it like those instead of that?
We are no longer going to be doing Bohr diagrams. We're going to be doing everything by Lewis structures.
So that's good.
This is what we're going to do, yeah.
Oh, good.
That's fabulous.
And then this is your bonding pair of electrons. So electrons want to be in pairs. A pair being 2. You wear 2 socks. You don't wear 3 socks. So a pair of electrons together. If we were going to do oxygen, it becomes a bit messier. O2, so there's 2 oxygens. Here's my nucleus. Here's my 2. Inner. How many valence electrons does oxygen have? 6. How many more does it want? 2. So it's got to share 2 in order to gain another 2. You share 1 if you want 1 more. You share 2 if you want 2. You share 3 if you want another 3. So it's going to have 2 electrons closest to the next one, and then the rest of them are evenly spaced out. You're going to pretend that my circles actually touch. So here, between the 2 of them, we actually have 4 electrons. 2 pairs of 2. Okay, 2 pairs of 2. But this is really messy. Really messy, so we're not going to do that anymore. What you can do is you write down your element symbols. How many electrons are shared between the 2 of them? How many electrons are shared between them? 2? 4. 2 pairs of 2, so 4. So there's my 4. How many lone pairs does each oxygen have? How many pairs of lone electrons does each have? That would be these guys. That's a pair. They're alone. 2. Each oxygen has 2 lone pairs, and I put them over here like this. Sorry, this is really messy. I'm trying to make it big enough for you to see. Okay, so this oxygen now is surrounded by 2, 4, 6, 8 electrons. This oxygen, 2, 4, 6, 8 electrons. So by sharing, it fills its octet necessity, okay? So it's got its 8s, but it didn't take any. So there we've got bonding electrons in the middle, lone electron pairs at the end, and they're spread in a way that gives them the greatest distance between each other. This kind of makes a triangle. Okay? These are going to be 120 degrees from each other. Electrons repel. They want to get as far apart from each other as they possibly can, whether they're bonding or alone. Curtis? Should be an O for oxygen. Okay, we call this type of bond a double bond, whereas we call this one a single bond because double, there's 2 bonds. Single, there's 1. Triple, there's 3. Okay? The pull on electrons that an atom has for electrons on, or for electrons in a bond. So this is the pull an atom has for its bonding electrons. And what this is a number scale that goes from 0 to 3.3. Where you are on this line will tell you what type of bond you have. And we get it by figuring out the difference in electronegativity. So that's a triangle. So that means difference. En, electronegativity. So the difference is either 0 or something in between 0 and 3.3. So 3.3 is the biggest difference we can have. If you are exactly 0, there's no difference in the pull whatsoever, you are pure covalent. You are pure covalent. If you fall between 0.5 and 1.7, you are a polar covalent bond. Polar covalent bond and shape will determine whether or not a molecule is actually polar or not. If you are greater than 1.7, we say you have ionic characteristics. You can be covalent and fall in that range. You can also be ionic and fall between 0.5 and 1.7. So it's really crucial you look at the elements in the compound before you say if it's ionic or covalent. But if you are a covalent compound and you're greater than 1.7, then you've got ionic characteristics. If you are between 0.1 and 0.4, if you fall in that region, you are considered non-polar covalent. So your bond is covalent, it's non-polar, but it's not pure. It just means you're not a little bit polar. You're not polar at all.
If you're 1.7.
If you're 1.7, you'd have ionic characteristics. Or be a very polar covalent. Either one. Very good. It means the same thing.
Oh.
It's the same thing. Okay. So actually, you know what? Let's say that if you are 1.7, you're polar covalent. For us. For us, we're going to say that. You can go to university and a professor might say you're non-polar until you get to 0.4. It depends who your professor is. Okay? So we'll set up our rules for us. 0.1 to 0.4, non-polar. 0.5 to 1.7, polar covalent. Above 1.7, you have ionic characteristics. 0, pure covalent. So let's take a look at hydrogen iodide. What kind of a covalent bond does it have? Say?
Non-polar.
It is a non-polar covalent bond. Non-polar covalent bond. How about the bonds between carbon and oxygen and carbon monoxide? What is the electronegativity difference between these two atoms? So find carbon. What's the electronegativity of carbon?
2.5.
2.5. What's oxygen?
3.5.
3.5. So the difference is 1 exactly. What type of a bond exists between carbon and oxygen and carbon monoxide? Saeed,
Polar.
do you agree? Yep, it's a polar covalent bond. Once we get a little bit more into shapes, you'll be able to predict whether a molecule is actually polar or non-polar based on the types of bonds it has. All right. So next part here, it says this is the type of bonding which results when one or more pairs of electrons are shared between atoms. So covalent bonding is the type of bonding which results when one or more pairs of electrons are shared between atoms. So for example, Cl2. Cl2 is the molecular formula. So that's the molecular formula for this element. It's the symbols that represent what the compound or element is. So molecular formula. MF for short. Okay, so the Lewis structure. You can either do your Lewis structure using dots for the bonding pair, or the stick for the bonding pair. But whatever you do, don't forget to put in the lone pairs of electrons. Okay? Each atom should show the correct number once it's full. So chlorine wants 8. It's now surrounded by 8. Right? Because there's 2 in that bond. 2 in that bond. Okay, so that's a Lewis structure. I'm going to ask you to do structural formulas. The only thing a structural formula shows, the atoms and the bonds. So no lone pairs of electrons. So because there's no lone pairs on hydrogen, your structural formula is identical to your Lewis structure. Okay, oxygen, O2. Oxygen has 6 valence electrons, needs 2 more. So it's going to gain them by sharing 2 with a neighboring atom. So 2 were used in the bond, which leaves the remaining 4 from its valence electrons. So there we go. Each oxygen is surrounded by 8. Structural formula, just the bonds and the atoms. So this is oxygen gas. Nitrogen. How many valence electrons for nitrogen? This is key to how many bonds it's going to make. How many valence electrons?
5.
5. 5 valence electrons. Is anybody, because nitrogen needs 3 more electrons, it's going to make 3 bonds. So that takes care of 3 of its valence electrons. The other 2 go over here. So, of these, 1, 2, 3, 4, 5, that 1, 2, 3 came from the other nitrogen. Came from the other nitrogen, who also had 5. So there's its 3, 4, 5. You could also draw it like this. Because that gets messy, right? It gets messy. So, nitrogen, structural formula. Doesn't show lone pairs of electrons. This is called nitrogen gas. Any questions so far? With the exception of hydrogen, we're bonding so that we fill up our octet, right? We're filling so that we get 8 electrons surrounding each atom. Carbon's got 4. So it needs to make 4 bonds because it needs 8. Hydrogen has 1 electron. So by sharing its electron with carbon, carbon's now surrounded by 2, right? Hydrogen's surrounded by 2, and carbon is surrounded by 8. So, so your Lewis structure can look like that, or it can look like this. There's your Lewis structures. There's your structural formula, because there's no lone pairs of electrons. They're all bonding. This is the common name for methane. The IUPAC name, the way you're going to be naming it, it's carbon tetrahydride. Carbon tetrahydride. Now, methane is something that's produced when you're decomposing, but there's no oxygen present. So this happens in your tummy. So when you toot, that's what comes out, methane. Dumps have to vent. They have pipes coming out of the ground because there's so much methane made that the whole thing would explode if they didn't vent the gas out.
Oh, would it not be possible?